algorithm is used to find the minimum spanning tree for a given weighted graph. A given weighted graph of n nodes, Prim's algorithm is used to find the tree having n nodes and n minus 1 edges such that the sum of weights of these n minus 1 edges is the minimum of all possible trees. So, Prim's algorithm is used to find the minimum spanning tree for a given weighted graph. So, this is the simple algorithm for the Prim's. First point, start with any vertex of the given graph. How can we follow the Prim's algorithm? How can we find out the minimum cost spanning tree by using Prim's algorithm is, first we have to start with any vertex of the given graph. This is the first point. Start with any vertex of the given graph. What is the second point? Find the edges associated. Find the edges associated with that particular vertex and add minimum cost edge to the spanning tree. Find the edges associated with that vertex and add minimum cost edge to the spanning tree. If it is not forming any cycle, when we have to add that particular edge to the spanning tree, if it is not forming any cycle, then only we have to add that particular edge to the spanning tree. Suppose it is forming any cycle, then discard that edge. So, discard that particular edge. Third step is repeat step 2 until all the vertices are covered. So, these are the 3 properties we have to follow for the Prim's algorithm. First one is start with any vertex of the given graph. Second one is find the edges associated with that vertex, add minimum cost edge to the spanning tree if it is not forming any cycle. Suppose it is forming any cycle, then discard that particular edge. Repeat step 2 until all vertices are covered. Now see the example for the Prim's algorithm. So, this is the graph we have to take for the Prim's algorithm. Before that, the graph G of V comma E, vertex comma edge given below contains 9 vertices and 12 edges. We are supposed to create a minimum spanning tree. At T of V comma E for G of V comma E such that the number of vertices in T will be 9 and edges will be 8. Why? The spanning tree follows one rule, that is, if the graph contain n vertices, then spanning tree contain n minus 1 edges. So, here the graph contain 9 vertices. So, the spanning tree contain 9 minus 1 edges, that is 8. Right? Next. So, this is the given graph for the Prim's. Step 1. How can we find out the minimum cost spanning tree by using Prim's algorithm? So, this is the example. Already we know that primarily to begin with the creation of MST, minimum spanning tree, you will choose an arbitrary starting vertex. Let's say node A. Starting vertex node A. We will take any vertex from the given graph. Now we will take the node A is our starting vertex. This means it will be included first in your tree structure. So this is the starting node vertex. Next. Now see, after the inclusion of node A, you will look into the connected edges going out from the node A and you will pick the one with a minimum edge weight to include it in your tree. So, this is the given graph. We already know that starting vertex we have to choose, that is A. Now, we have to check what are the different edges associated with that particular vertex. Now, this is the starting vertex. What are the different edges associated with that particular vertex? B and C. So these are the two adjacent edges associated with the vertex A. So here we have to take, now you have to reach node B. From node B there are two possible edges, out of which edge BD has at least edge weight value. So you will include it in your minimum spanning tree. Now see, here we have two adjacent edges, that is A to B and A to C. Why we are choosing B? Here we have to take the minimum cost value. So here the weight of the A to C is 6. Here the weight of the A to B is 1. So whenever we want to select an adjacent edge, we have to check which edge is the minimum weighted value. We have to select that particular edge only. So here we have the minimum cost value is 1. So we have to select adjacent vertex B. So here we have to choose A to B. Next, from node A to B, from which one is the new vertex here? B. So from B to, what are the adjacent edges from B? Here B to D and B to F, B to A, but B to A is already completed. So now we have to check B to D and B to F. So which one is the minimum value here? 3. So that's why here we have to choose B to D. So A to B is 1 and B to D is, the weight is 3. Next we have to see new vertex is formed, that is D. From D onwards, what are the adjacent edges related to D? So from D we have only one adjacent edge, that is H. So automatically we have to take D to H, that is 7. Now new vertex is formed, that is H. From H to, what are the different adjacent edges formed? H to I and H to G. But here the minimum value is, here it is 9 and here it is 3. So what is the minimum value? 3. So that's why we are taking H to I, that is weight 3. Next we have to see I vertex will be formed. From I to, what are the adjacent edges we have here? H to I already completed. So we will not take that particular edge. From I to G. So this is the only adjacent edge from I. So I to G 4. From G, new vertex is formed, that is G. From G to, what is the new adjacent edge? Here H to 9. 9 is there. But whenever we have to draw H to I, here the cycle will be formed. So we will not take this particular edge. So simply we have to remove this edge. Now what is the adjacent edge from G? E is the another edge. So G to E, the weight is 2. Next, another vertex is formed, that is E. So from E onwards, what are the different adjacent edges? Here we have F and C. If suppose we have to take F, here the cycle will be formed. So that's why simply we will not take this edge E to C. So here the minimum value is 2. So that's why we have to take E to C. Now another vertex formed, that is C. That is C. So whenever we have to take the C, what are the adjacent edges related to C? C to A. But whenever we have to draw C to A, here the cycle will be formed. So that's why we will not take this particular edge. If suppose we have to take C to F